All right, we are covering solving systems of linear inequalities. So we are going to learn how to solve systems of linear inequalities, just as the title of the section says. Please remember to take your notes and do the check it out problems. All right, so a system of linear inequalities is just a set of two or more linear inequalities. That means it has a greater than or less than sign in it with the same variables. So this is important. The solution is an infinite set of points that's represented by a shaded part of the graph. And when we graph multiple inequalities on the same graph, the region where the two shadings overlap is the solution of the system of inequalities. Let's look at an example. Here's our first system of inequalities. So y is less than 1/2 x minus 3, and y is greater than or equal to negative x plus 2. So you would treat these as you would if they were separate inequalities. You're going to graph of each of these inequalities by graphing your boundary line, and your boundary line is the line defined by your equations here. And this one is going to have a dashed line because it's got a less than and not an equal. This one will have a solid line because it's got a greater than or equal. So they have it graphed for you, but the first one has an y-intercept of negative 3, and it has a slope of 1/2, so you're going to go up 1/2, and they have the dashed line here to represent the less than. And y is less than that, so they shaded this part underneath that boundary line. The second one, it has a y-intercept of positive 2 and a slope of negative 1, so we're going to go down 1/1, solid boundary line, and its y is greater than or equal to that, so we're going to shade this. And what's our solution? Our solution is going to be this part of the graph. Let me use a different color. This part of the graph where the two actually overlap. So this is our solution region, and it would potentially go on infinitely as the lines extend out. So the overlapping region is the solution to that system of inequalities. All right, so if you are unsure which region or which side of the line to shade, remember you can test the origin. So if you pick the point 0, 0, plug it into your inequality. If it's true, that means this is in your solution region, and that's the area that you should shade. If it's false, then that means it's not part of your solution region, and you would shade the side of the line that doesn't include 0, 0. All right, so we will do another example. Here's a system of inequalities, sorry. So again, we're going to graph each of the lines. This is y equals negative 3x plus 2, so our slope is 2. Our y-intercept is 2, our slope is negative 3. Here, this is going to be a horizontal line, y equals negative 1. So here are our two sets of lines. Notice this one is dashed because we have no equality here. This is going to be a solid, so this is y equals negative 1 right here, and this is y equals negative 3 plus 2, and this is dashed. All right, which side of the line? Well, y is less than this line. Which side is the less than side? Well, if you're not sure, again, you can test this point 0, 0. If I plug it in, I have 0 is less than negative 3 times 0 is 0 plus 2. 0 is less than 2. Is that true? It is. So that means for that line, we're going to shade this side. This one is y is greater than negative 1. So here's negative 1. Here's our line. Y is going to be greater than that. So we're going to shade this side. And what's the intersection of those two? The intersection is going to be this part right here. So this is our solution region. Okay, So now you will do this check it out problem, graph the system of inequalities, and shade in the solution region. And you will do a second one as well. All right, so let's look at an application of systems of inequalities. Lauren wants to paint no more than 70 plates for the art show. It costs her at least $50 plus $2 per item to produce red plates and $3 per item to produce gold plates. She wants to spend no more than $215. Write and graph the system of inequalities that can be used to determine the number of each plate that Lauren can make. So you can probably see we have a couple of inequalities and they're based on the constraints. What are the constraints? Well, no more than 70 plates and no more than $215. So we know we're going to assign variables to our items and write our system of equations. So we're going to have X represent, let me actually use red for red plates. X is our red plates and Y is going to be our gold plates. So if we want to write a set of inequalities, the total number of plates has to be less than or equal to 70. So the first inequality is going to be X plus Y. So number of red plates plus number of gold plates has to be less than or equal to 70. Then we're also constrained by money. So the amount of money is $50, which is the amount that it costs her, the startup costs, I guess, and then it's $2 for red plates, $3 for gold plates. So all of that has to be less than or equal to 215. There's also a couple other implied constraints which you probably know but didn't think to write down. And they are these two here. So X has to be greater than or equal to 0. We can't make negative plates. So these are kind of implied. And what it means is your graph is going to be in the first quadrant of an XY graph. Whoops. So if you were graphing, quadrant 1 is right here. And this is where your solution is going to be. You don't have to worry about the other three quadrants. Why? Because you're not going to have negative plates. All right, so we're going to take this system of equations and graph them. And as I said, we're not worrying about any of the other quadrants, so we've only got a quadrant 1 graph. Here's our origin. We graph the line x plus y equals 70. That's this red line. And we have to have less than or equal to 70, so we're going to shade underneath that line. And then we're going to graph 50 plus x plus 2x plus 3y is less than or equal to 215. How would you do that? Well, I would subtract negative 50 from both sides to get 2x plus 3y is less than or equal to 165. And then I would find my intercepts by setting my x to 0 and my y to 0. So here's my y-intercept, here's my x-intercept, and this is my line for this equation. And now we know that that also has to be shaded underneath the line. So we've basically graphed those inequalities, and that gives us, these are our possible, this is our solution set. So that means any dot, any point in that solution set will satisfy all of those constraints we have of number of items or number of plates we want to make, as well as the amount of money that we want to spend. All right, so I'd like you to try to do a similar thing. Here's your problem. Try and set up your system of equations. So you're going to write and graph. Whoops, that's not very nice color. We want you to write and graph the system of equations or system of inequalities that models this. So find your inequalities and see if you can graph it. This kind of brings us to our last topic, which is graphing more than two inequalities. So this says graph the system of inequalities and classify the figure created by the solution region. And we're going to look at our boundary lines first. So if we look at the boundary lines we want to draw, this is just going to be x equals -2. This boundary line would just be x equals 3, y equals -x plus 1, and y equals 4. So it's a lot of inequalities, but the lines that you have to graph are pretty simple. And here they are. So this is x equal 3. This is y equal 4. And this is our -x plus 1. And our last one is, this is x equals -2. So if we look at the area bounded by all of those, and we have to look at the inequalities. So let me write down the inequalities. They had them. X is greater than or equal to -2. So that means it's going to be shaded in this direction. And then we had x is less than or equal to 3. So basically, we're bounded in the on the x-axis between -2 and 3. For y, we have y is greater than or equal to -x plus 1. So if we draw our line here, it's going to be shaded in this region on this side of that line. And then our last one is y is less than or equal to 4, which is underneath. So the area that would be shaded by all those inequalities is this. And that looks like a trapezoid of some sort to me. We've got two parallel lines. So I think it said to classify the figure, and it should be classified as a trapezoid or a quadrilateral. Okay, so you will try to do one of those. Here's your check it out problem. Make sure you write down any questions, and I will see you next time.